Hi, my name is JiaqiZhang. Today I would like to present my Project 2 on house pricing prediction. First off, to get an overview of the project, we're provided data in 3 separate files with features about the house and its sales prices in College Circle, Edwards, and Old Town. So the goal was to, for this project, the goal was to develop a model based on the data to predict the missing sale prices. So the data processing steps, here are the follows. First off, the 3 provided data sets are combined together to have more data for training. For example, a field neighborhood is created based on the file. If a house is in the College Circle file, then the neighborhood is called College Circle. With more features, the model will fit the training data better, but at the same time increases the risk of overfitting. And also features are initially selected based on personal home purchasing experiences, so that it includes the features that are most relevant in determining the sale prices. Now let's talk about the finally selected features. Generally, the features were divided into 2 groups, continuous and discrete. So here we have the continuous features. I'm going to go through the list one by one. First one we have here is the year built, which means tell by the words like the house, which year the house was built. And also similar the year sold, so both of them are from the original data. And then we have the lot size, is derived from the lot info feature, and also bedroom, number of bedrooms, and then also features about living area. Those are also from the original data. Also talking about bathroom, we have number of full bathrooms and also the number of half bathrooms. They're also from the original data, and now and then we have total rooms, features for the total number of rooms, also from the original data. And last but not least, we have the overall condition feature, as well as the overall quality feature for the database. So both of them are also from the original data. Now let's look at the discrete features. First off, we have neighborhood, like we talked about before, is derived from the data set. And then if a house is in the College Circle file, then the neighborhood is called College Circle. And then we have following features that are related to the house itself. First off, we have the house style. It generally talks about how many levels the house has. For example, like 1, 1.5, 2, or 2.5. And then we have building type. Building type is basically talking about the style, the building style. The style, either it's a single family, a town, or a twins. And then inside the house, we have kitchen quality. Kitchen qualities can be excellent, can be good, or it can be average. And then move on to garage type. Garage can be either attached or detached. Heating system. The condition of the heating system, it can be good, can be fair, or average. And moving down, we have the features about basements. First off, the with basement feature is derived from both the 2 fields listed here. And then it's an indicator about whether the house has a basement or not, like you can tell based on the wording here. And then if you have a basement, then we have the finished basement feature. It's also derived from this basement field listed, and then it's an indicator about if the basement is finished or not. And then last we have with central air feature. It's also derived from the original data, and then it's an indicator about if the house has central air system or not. Now we have the data ready. Let's move on to the interesting part, modeling. So I'm going to talk about the methodology I used here. I used XGBoost for the regression model for following reasons. First, XGBoost is an efficient implementation of gradient boosting algorithm. It can be used for regression modeling, and it has high performance and precision. But there is a disadvantage of the model is that it's difficult to interpret the results. And then from the problem statement, the client is more interested in the accuracy of the model and is willing to sacrifice certain degree of interpretability. So as a result, I chose XGBoost for the model. So XGBoost generally has many parameters that can be tuned for best performance. Here, the tuning was conducted using the grid search with cross-validation for the hyperparameter tuning. And below here, I listed the parameters for the grid search. First one, I had max depth. It's from 2 to 10 with 1 as the increment. And then I have the number of estimators is from 40 to 200 with 20 as an increment. And then last I had learning rate it could be 0.01, 0.05 and or 0.1. And then for the cross validation, I use 5-fold cross validation. Now that we have both the data and modeling ready, let's move on to prediction. So the testing data sets are processed using the same scripts that are developed for the processing of the training data. And then the trained XGBoost model with selected hyperparameter is applied for making the predictions. And here we have it. This is my walkthrough of the project number 2. Thank you.